Hello. If your loved one has been diagnosed with mesothelioma, if your loved one has ever been confused about the concept of serial dilutions in chemistry, we are here to help. I'm Trevor.
I'm Katie.
I'm Alec.
And today, we're going to show you how to do serial dilutions.
Let's get started.
In chemistry, serial dilutions are used to repeatedly change the molarity of chemicals to produce a series of desired concentrations.
Cereal? I love cereal. Good thing I brought my Cocoa Puffs. I'd love to dilute it with some milk.
Not that kind of cereal, silly. We're talking chemicals here. For serial dilutions, the dilution factor of each step is constant, resulting in geometric pattern of reduction of the chemical solutions.
Oh, that's right, that kind of cereal. To demonstrate this process today, we will be diluting a solution of iron nitrate from a 0.1 molar solution to a 0.001024 solution.
First, we're going to need to gather our supplies. We're going to need our iron nitrate, a balled pipette, some beakers, our graduated cylinder, writing supplies, and some paper.
Thinking of calculations allow us to show you just how serial dilutions work from a mathematical analysis point of view.
From previous labs, we know that molarity, or concentration, of a solution is dependent on the volume of the liquid and the mass of the solute. By multiplying mass times volume, we get our molarity. Wait, that's wrong. Here we have our 0.1 molar iron nitrate. Using our bulb pipette, I'm going to measure out 5 milliliters used in our dilution. I'm going to add this to our first beaker.
Here we have our distilled water, and use a different bulb pipette to get 7.5 milliliters of the water.
And now we have successfully created 0.04 molar iron nitrate. Now that we've made 12.5 milliliters of our 0.04 molar iron nitrate solution, we're going to take 5 milliliters of that solution and dilute it to 0.016 molar iron nitrate. To do this, we'll use our M1V1 equals M2V2 equation once again, and after doing this calculation, we found that we need 12.5 milliliters of total liquid, meaning that we'll need 7.5 milliliters of distilled water to add to our 5 milliliters of 0.04 iron nitrate.
Now that we created this much of 0.016 molar, we are now going to dilute 5 milliliters of the 0.016 molar to 0.0064 molar to create another total of 12.5 milliliters of liquid with 7.5 milliliters of distilled water.
So now we take 5 milliliters of our 0.0064 molar iron nitrate, and we're going to dilute it to 0.00256 molar. Using the M1V1 equals M2V2 equation, we see that we also need 12.5 milliliters of total liquid for this equation. So we need 7.5 milliliters of distilled water added to our 5 milliliters of the previous diluted iron nitrate.
For our final dilution, we're going to take 5 milliliters of our recently created 0.00256 molar iron nitrate and dilute it to 0.001024 molar iron nitrate. We do this again by using our equation M1V1 equals M2 times V2, and we find that we need 12.5 milliliters of total liquid, so we'll add 7.5 milliliters of distilled water to our 5 milliliters of 0.00256 molar iron nitrate. As you can see, as we dilute our iron nitrate again and again, the color of the solution becomes lighter as we decrease the concentration. Here was our original concentration of iron nitrate at a 0.01 molar, down to a 0.04 molar, down to a 0.016 molar, to a 0.0064 molar, to a 0.00256 molar, and finally our 0.001024 molar solution. In our Beer's Law lab, we learned that concentration of a solution is directly related to its absorption of light. The higher the concentration of a substance, the higher light absorption it's going to have. To demonstrate this in our Beer's Law lab, we took 1.5 milliliters of our diluted iron nitrate solutions and mixed it with 1.5 milliliters of potassium cyanide. We will do that now into our cuvette. In the Beer's Law lab, we took all of our dilutions of iron nitrate and mixed it with 1.5 milliliters of the potassium cyanide and tested them in the colorimeter to test their absorbance.
Bill Nye the Science Guy. Bill Nye the Science Guy.
I know how we can relate it to the milk for my cereal.
It's like when you take a full cup of the rich chocolatey milk, but you don't want it all that chocolate, so you pour half of it into a clean, not chocolate milk.
And then you add some white milk
Now
to
it's
dilute the
diluted.
concentration. And then you take that milk
And you pour half of it into another cup.
and then you add even more white milk. And then you take that cup,
Do it one more time.
and you add even more white milk for a nice dilution of different concentrations of chocolate milk.
Now that you know how to do cereal dilutions, you can hide them.
Now that you know how to do cereal dilution, you can pole vault.
Action.
Now that you know how to do cereal dilutions, you can throw discus! Ah!